Hello, my name is Jacob Lee, and I'm going to teach you how to solve optimization problems. So for the first problem I have here, Nick is a lifeguard and spots a drowning child 60 meters along the shore and 40 meters from the shore to the child. Nick runs along the shore for a while and then jumps in the water and swims there directly to the child. Nick can run at a rate of 3 meters per second and swim at a rate of 0.9 meters per second. How far along the shore should Nick run before jumping into the water in order to save the child? So a problem like this, it's easiest to start by visualizing it. So we'll take all the variables and figure out where they belong and what we still need. So I'll start by just drawing the shore, the distance to the shore, and the distance to the child in the water. And this will be him swimming. So at what point will he start swimming? So we know this starts at 0, 0, and at the end, he'll be at 60, 40. We know this distance is 40 meters, and the distance between where he swims and how far he is going to be 60 minus x, with this whole length being 60. And then this length in particular is going to be x, and we'll need to find this distance as well. And in order to find the distance, we'll use the Pythagorean theorem. And finding the Pythagorean theorem for that angle in particular, it is 40 squared plus 60 minus x squared, and then just the square root of all that. And we'll need our formulas for the time and then distance he's going to be running. So how long it's going to take is time, the delta r, which is him running, and then delta s, which is him swimming. And then putting that into actual notation will be 1 over 3x plus 10 over 9 x squared minus 120x. Move this over. 120x plus 55200 and a half. All right, and then this x squared is just the Pythagorean theorem, just expanded. Next, we're going to find the derivative of this equation. So the derivative is going to be 1/3 plus 10 over 9 times 1/2 x squared minus 120x plus 5200 to the negative 1/2 power times 2x minus 120. And then simplifying this further is going to be 1/3 plus 5 over 9 times 2x minus 60 x squared minus 120x plus 5200. All right, so now we have our derivative equation. We want to find the zeros of this equation because those zeros will help us find that distance we'll need. So we'll set the equation equal to 0. So 0 equals 1 over 3 plus 5 over 9 minus 60 x squared minus 120x plus 5200. So first we'll set everything, we'll multiply that 5, 9, and then put the 1/3 on the other side. So it'll be negative 1/3 equals 10, 9, x minus 60, square root of x squared minus 120x plus 5200. I'll multiply the whole equation by 3. X squared plus 120x plus 5200 equals 10 times x to the 60. All right, next we'll divide both sides by 3. And we'll factor out the, we'll factor this equation at the x squared plus 120x plus 5200. That'll just make it easier. Later you'll see 1800 equals 10 over 3 x minus 60. And now with this, we have x minus 60 right here on both sides, and we'll make that substitute for u. So u is going to equal x minus 60. Now we have square root of u squared plus 1600 equals 10 over 3 u. And now with this one, it'll be a lot easier. Or actually, we'll square both sides, so this will end up being squared. Now we just solve for u. So 4400 equals 91 u squared. And then divide by 91 and square root. So 144 over 91 square root plus or minus equals u, but we still have u, and u is going to equal that x minus 60. And we just add 60 to both sides. So now our final equation is 60 plus or minus the square root of 144 over 91 equals x. And now we have our x, and for his distance that I'll be running, and that final solution is this. So we need the one that actually works in this equation, and in this case it is 47.420 feet, or was it feet or meters? Meters. And the other number here was, I believe it was 71 something. That number is far too high. Since we're only running 60 meters, he can't run 71 meters. So it's going to have to be this 47.420 meters. Then that is how you solve optimization problems. Thank you for watching. I hope you learned something. Thank you.